Hello everyone! In this video, we will explain model evaluation and the confusion matrix. These are essential concepts in machine learning classification. After building a classification model, we must answer one question. How good is our model? This question is at the heart of everything we do in AI development. This is called model evaluation. It's the standard process for assessing performance. To evaluate a model, we usually test it using new unseen data, not the training data. This helps us measure how well the model generalizes to real-world scenarios it hasn't encountered before. Many students think we only use accuracy, but accuracy alone is often not enough. We also use other metrics like precision, recall, specificity, and F1 score to get the full picture. To calculate these metrics, we use something called the confusion matrix. Now let's understand the confusion matrix. A confusion matrix is a table that compares actual values with predicted values. It has four important terms: true positive, true negative, false positive, and false negative. Let's understand each one using a medical example. Suppose we build a model to detect drug toxicity. The model predicts whether a drug is toxic or safe. This is a binary classification problem. First, true positive. This happens when the drug is actually toxic, and the model correctly predicts toxic. So this is a correct detection. It's exactly what we want our model to find. Second, true negative. This happens when the drug is safe, and the model correctly predicts safe. This is also correct. The model successfully identified a safe sample. Third, false positive, also called a false alarm. This happens when the drug is actually safe, but the model predicts toxic. So the model raises an alarm, but nothing is actually wrong. It's an unnecessary concern. Fourth, false negative. This happens when the drug is toxic, but the model predicts safe. This is the most dangerous mistake, especially in pharmaceutical applications where safety is critical. Using these four values, we can calculate various evaluation metrics to judge our model. First, accuracy. Accuracy measures overall correctness across all predictions. Accuracy equals true positives plus true negatives divided by total predictions. This tells us how many predictions are correct overall. It's the most intuitive metric. However, accuracy can be misleading when data is imbalanced. This is a common trap. For example, if most drugs are safe, the model may predict everything safe and still get high accuracy. That's why we use precision and recall to get a deeper understanding of performance. Precision tells us, of all drugs predicted toxic, how many are actually toxic? Precision equals true positives divided by true positives plus false positives. High precision means fewer false alarms. You can trust the model when it says toxic. Recall, also called sensitivity, tells us, of all real toxic drugs, how many did we detect? Recall equals true positives divided by true positives plus false negatives. High recall means we detect most toxic drugs. We don't want any dangerous ones slipping through. In pharmaceutical applications, recall is very important because we do not want to miss toxic drugs. We also use specificity to look at the safe drugs. It's the other side of the coin. Specificity tells us, of all safe drugs, how many did we correctly predict as safe? Specificity equals true negatives divided by true negatives plus false positives. High specificity means fewer safe drugs are wrongly rejected. It's about maintaining efficiency. Finally, we use F1 score. This is a balance between precision and recall. It is calculated as 2 times precision multiplied by recall divided by precision plus recall. F1 score is useful when the dataset is imbalanced. It's a single number summarizing 2 key traits. To summarize, accuracy measures overall correctness. Precision measures correctness of positive predictions. Recall measures ability to detect positives. Specificity measures ability to detect negatives. F1 score balances precision and recall. These metrics together give us a complete understanding of model performance. Never rely on just one. And all of them are derived from the confusion matrix. It's the foundation of everything we've discussed. That's why the confusion matrix is one of the most important tools in evaluating classification models. Thank you for watching this explanation. Good luck with your AI models!